Okay, here is my presentation on clouds. I've got a video there that you can go in and watch on your own. So a cloud is a visible mass of liquid or frozen water droplets that are suspended up in the troposphere. Remember, the troposphere is actually the bottom of the atmosphere, so clouds actually don't go up very high. They're pretty close to the ground. Now, adiabatic cooling, it's a fancy word. What it basically means is that as air pressure goes down, air actually gets colder. Here's why this matters. When air rises, so if air is, let's say that we have air at the surface that is going up into the sky. Um, as that air goes up, it's actually going to expand and the pressure will decrease. So if air starts rising, once again, when air rises, it expands. The air takes up more space. And when the air starts expanding, it gets colder. So let's look at this diagram right here. This diagram is showing a nice sunny day. It's 90 degrees on the ground. It's like summer in Atlanta. But if that air starts getting hot because of the sun heating up the ground, when the ground starts heating up the air, that hot air is going to start rising because of convection. Remember that hot things naturally expand and rise. So this hot air starts rising. Once that air gets up to 1,000 feet, it has expanded, as you can see by this gray area that has gotten bigger. That represents the size of this air parcel right here. So the air has expanded, and that expansion has caused it to get, it looks like 5.5 degrees colder, down to 84.5 degrees. But that air is going to keep rising. By 2,000 feet, it has cooled off to 79, and by 3,000 feet, it has reached 73.5, which appears to be the dew point for that air. So that is the temperature at which the air is now 100% saturated. That's why this cloud starts forming. Oops. So that cloud starts forming right here. But that air does not stop rising, keeps rising, gets even cooler. And if the air is going to be getting colder than the dew point, that means water is going to have to come out of the air. So you'll start having big dew droplets form up here. The air keeps rising, keeps getting cooler down to 67. This is when you're going to start having rain really developing. So as this air keeps getting higher and higher, it keeps getting colder and colder, and more water starts coming out of it. And this is how you end up with a thunderstorm on a hot summer day. It started with the ground getting heated up, ends with this air going way up in the sky, and all of the water has to fall out of it because that air expanded and got colder. It's a little bit confusing to follow, but it is why we have thunderstorms in the summer. I did a demonstration in class where I actually made a cloud inside of a bottle. It's kind of a fun demonstration, but it's hard to replicate if you were not in class. So here is the cause of clouds. Clouds are caused by rising air reaching the dew point. This can be due to either falling temperature and decreasing pressure. So I went over this in the last slide, but once again, if you've got a hot summer day, the sun actually heats up the ground. It doesn't heat up the air, it mainly heats up the ground, and then the ground heats up the air. And that hot air starts rising. When it rises, it gets cooler and it reaches the dew point, which makes a cloud form. And that cloud keeps on getting higher and higher and higher. And all of that water keeps coming out of the air until eventually those water droplets get big enough to start falling back down to earth. And this is how you get a big thunderstorm cloud. This is a mature thunderstorm right here. This is a dissipating storm that has pretty much blown itself up at this point. Here's another video that you should watch. You're going to need to go back to the presentation to access it, though. So here's a review question. As temperature decreases, what does relative humidity do? You can look at this graph to answer that question. You can see right here that as temperature is decreasing, relative humidity is increasing. The reason for that is that colder air cannot hold as much water. So as the air gets colder, it's also going to be getting more saturated with water. That's why the temperature graph and the relative humidity graph do the opposite things during the day. As you can see, at the hottest part of the day right here, the air is at its relative driest, only about 30% saturated. Whereas in the morning, when it was colder, that air was almost at 100% saturation. So relative humidity and temperature do the opposite of each other. There are three primary cloud types. Number one is a cumulus cloud. These are classic clouds, my favorites. These are puffy, low clouds that are caused by air that has been heated up by the surface. This air rises into the sky. So in this picture, the sun has been heating up the ground right here, and that hot ground heated up the air and made it rise. Once that air hits the dew point, you have a cloud form. That is a cumulus cloud. These tend to form during the hottest part of the day, since that's the time of the day when the ground is hot, which causes the air to rise. You don't usually see these at nighttime, although they can be caused by a cold front, which can also cause air to rise. And a cold front could happen at nighttime. A cumulonimbus cloud. These are thunderstorm clouds. Nimbus just means rain. So these are just giant cumulus clouds that have gotten so big and so explosive that they start having hail inside of them. The hail collides with other pieces of hail. This creates friction, which ends up resulting in static electricity building up, which makes lightning happen. This is just like a big thunderstorm right here. A cirrus cloud, pictured here, is a thin, wispy, high cloud that is made of ice crystals. These are not necessarily caused by air rising. They tend to be really, really high in the atmosphere. They look kind of feathery almost. Wispy is the key word. And a stratus cloud is a low cloud. It kind of just looks like fog that is high up in the sky. It tends to almost not even look like a defined cloud. This is more just like when it's totally cloudy outside. It's called a stratus cloud. They're not particularly exciting to look at. They can cause rain, though. That would be called a stratonimbus cloud if it causes rain. These are just some pictures of these are pictures that I've taken. I think this is actually my parents' lake house in Canada. That's my wife right there, I believe. So these are cumulus clouds forming in the afternoon when the sun is heating up the ground, causing the air to rise. That's what's making these clouds. You can see how they're getting a little bit dense at the bottom, which makes them look dark gray. But these are not going to be producing rain. They're just not big enough. This also looks like a cumulus cloud that is producing rain, but I don't believe that the rain was actually making it to the ground. The rain was evaporating before it hit the ground. That is called virga when that happens, Virga. Although you don't need to know that for your tests, but I thought that was pretty beautiful. It's cool to see rain falling out of the sky but not making it to the ground. This was at the Eagles Landing track one day. Just thought it was neat the way you can see these waves in the sky. Just kind of the way that air flows, kind of like water. Kind of neat. That would be a stratus cloud, though. These are some cirrus clouds at sunset. This was taken from the Eagles Landing faculty parking lot. This is a cold front coming through. So this would actually be some cumulonimbus clouds, probably. This is a squall line. This is taken from the Waffle House over by Union Grove High School. There's the McDonald's over there. That was a pretty epic sky. Those are some cirrus clouds. That is a cumulonimbus cloud, a thunderstorm. I took that picture from far away. That's a picture of me and my honeymoon. These look like some little cumulus clouds. Nothing too strong, though. That's in Costa Rica. This is another sunset picture, probably some cirrus clouds back here. These are some seagulls. Here